Well, thank you. My speech is on the value of soil biodiversity and ecosystem services from an economic perspective, ecological economic perspective, indeed. It's a joint work with these co-authors, Unai Pascual from the Basque Center of Climate Change, with Mette Termansen, Katharina Eldun, Libert Bouchard, Jacques Faber, myself, Philippe Lemanchot, and Cécile Jorgensen. We conducted this research during the EcoFinder project. Well, the objective was to try to understand this question of what is the value of soil biodiversity and ecosystem services. Because behind this question that looks simple, you have different concepts like values. How can we value such a thing? What kind of method can we use to value them? And behind it also this relation between soil biodiversity and the production of ecosystem services. So our goal was to provide a conceptual framework to understand this notion of soil biodiversity and ecosystem services, and also clarify some links between values and services when we deal with different timescales or different actors, like society in general, or on the contrary, farmers or private individuals. And also try to address how these values will impact and are impacted by management practices and by policies. So our framework is the one that you almost all know, is the Millennium Ecosystem Assessment. It is a utilitarian approach in which we maximize the individual use and the social satisfaction from allocating scarce resources like soil biodiversity. And the approach for valuing these ecosystem services from soil biodiversity is the total economic value, which is the value of the value that you get in changing the stock of soil biodiversity, but in all the services that soil biodiversity provides you. And so we consider that, well, soil ecosystem services is the action of soil organisms in providing a different kind of economic ecosystem processes. So the assumption that we have is quite to have a simple representation of these assumptions in the diagram. Well, we have considered that the regulating and the supporting services can be grouped into intermediate services. So we have like water flow regulation or nutrient cycling that are intermediate services produced by soil biodiversity. And these intermediate services, well, gives you provisioning services like fiber, crops, climate regulation, and also having clean water. And from these provisioning services, well, we have different values that some refers to individuals, like farmers, and others are more global, like they will affect society, like climate mitigation or having clean water. And this value will define the practices that society or farmers will do in terms of land uses, in terms of intensification of practices, or in terms of choosing the farming system, like conventional conservation tillage or conventional agriculture. And in turn, we have this loop because these practices will influence soil biodiversity and the provision of intermediate services. So it is a kind of simple framework that we have in mind to value the total to give the total economic value of soil biodiversity. Well, total economic value have different components. So, one is the total output value. It's the output that are produced and that we can value with tangible benefits. We have use values and non-use values. And in the case of soil biodiversity, the use value are the indirect use value of the intermediate services. Now, we do not value soil biodiversity directly, but we value the intermediate services it provides. For private agent, for example, we have water regulation or nutrient cycling intermediate services. Or for public and more global perspective, we have the greenhouse gas emission reduction or eutrophication reduction due to reduction of nitrogen, for example. And we also have other values like the option values, which means just keeping the option open for the future to discover new species or microbes. And also in the non-use values, we have the existence value of soil biodiversity, which probably can be less important in terms of valuation, contrary to emblematic species of biodiversity. But the other main block of this total economic value, and this is what we address in this paper, is the natural insurance value of soil biodiversity. And we have two different kinds of value that are self-protection, and the other is self-insurance. And I will now develop these two different insurance value of soil biodiversity. So what do we mean by insurance value? It consists in taking actions that reduce the income risk of somebody using ecosystem services. And from this, we know in economic literature that there are two main values. One is self-protection. So it consists in lowering the risk of being negatively affected by an event. So it's a kind of mitigation. An example from this is like, for example, investing in soil biodiversity. You can reduce soil-borne diseases because you introduce competitor to pathogens. So you will reduce the attack and the root infection, and then the infection to the plant. Another value is the self-insurance value. It's a bit different because it's the value of lowering the size of the loss. So in this case, the bad event has already happened. And an example, for example, it can be that investing in conserving soil biodiversity will promote, like for example with IMF diversity, this promotes the nutrition and the growth of the plant, which make the plant more tolerant to attacks from other kind of pests. So you will have a loss, but a lower loss than if you don't have IMF diversity or other diversity. Now I would like to show you in a graph this determinant of the natural insurance value of soil biodiversity. Well, consider this, well, it's an heuristic graph. So just consider this relationship between intensification and soil biodiversity. So after a threshold of intensification, soil biodiversity can reduce drastically. What are the consequences in terms of profit or in terms of yield? Well, you have this relation, well, yields are produced in this case with soil biodiversity and with intensification, like nitrogen and other fertilizers. And we have this usual relationship between intensification and profit or yields. So, as intensification in soil biodiversity increases, the profit increases, but after some point, the degree of increase is getting smaller, so we have this concave shape. And you can even have, for large intensification, a decrease of profit, because you would take into account the negative effect of intensification on soil biodiversity. But the other effect of soil biodiversity deals with risk and with the variability of this profit. Well, consider that when intensification is low and biodiversity is high, you will have this kind of variability of your profit. And on the contrary, when intensification is getting large and soil biodiversity low, you will have more variability of your profit and of your yields. What does this mean for the well-being of this farmer? Well, we represent this well-being in what we call the expected profit or expected utility of this farmer that take into account the distribution of this profit. So both the average and the variance and the variability of the profit. If the farmer do not care about variability, so we call this a risk-neutral farmer, And the expected profit we'll get will be similar to the profit curve. But on the contrary, if the farmer dislikes being in this area because he has a large variability, well, his well-being will be reduced. So in this case, he is what we call a risk averse. And after the point where variability increases, the expected profit decreases. So if the farmer is rational, if the risk-averse farmer is rational, instead of being in this point, he will prefer to be in point E, now where his expected profit will be larger. And in this case, this means that he will move from an intensification production to a less intensive production, meaning in this graph that he will invest in soil biodiversity in order to be in this part, or at least somewhere there, of the graph. And what he's willing to pay to avoid this risk, this variability, is this natural risk premium, so it's this quantity. Now, imagine that this farmer can go to the market and buy an insurance. This means that instead of, to cover against the risk, instead of reducing intensification and investing in soil biodiversity, he can go to the market and buy an insurance. Indeed, in Europe, we already have insurance that cover yields from flood, from drought, not from the reduction of soil biodiversity, but at least for other type of risk, we have an insurance. So what does this insurance do is that it will make this farmer behave as if he will be a risk-neutral farmer, because the insurance will cover against all this variability. So the farmer who go to the market will be in this point there, because the variability will be covered by the insurance, but we will have to pay for this insurance, and you will have to pay this quantity. So in the end, the expected profit will be around point E, but with a commercial insurance, not with a natural insurance. So what such a farmer, what is the decision for this farmer? Well, he will prefer the commercial insurance if, he will prefer the commercial insurance if it costs less than the natural insurance. And in this case, for this high risk-averse farmer, you see that the natural insurance is costlier than the commercial insurance. So probably this farmer, if there is an insurance in the market, will prefer to go to the market and intensify its production and do not invest in soil biodiversity. But on the contrary, if you have another farmer that is less risk-averse, like farmer 2, the natural risk premium he is willing to pay is this one, which is smaller than the commercial risk premium. So this farmer 2 will invest in soil biodiversity by reducing intensification of his production and investing in soil biodiversity, because his willingness to pay for natural insurance is lower than the commercial risk premium. So we see that it's quite complex decision making, because it implies different elements like the intensification and the soil biodiversity relationship that we have there. It also implies relation between soil biodiversity and the production of the intermediate services like regulation and supporting. So this means that this relation gives you the shape of this variability here, and also the relation between the production of the intermediate services and the final services that will depend on the risk preferences of this farmer, whether he is more or less risk-averse or risk-neutral, and also on the existence of surrogate insurance market. So why do farmers do not always choose natural insurance versus commercial insurance? Well, this depends on their risk on the degrees of risk aversion and on the existence of surrogate market. It also depends on the fact that individuals in society have different time preferences. If society will prefer to protect soil biodiversity, but farmers will have to bear the cost of this protection in the present and get the benefit probably only in the future. So this discrepancy makes that farmer will need an incentive to protect soil biodiversity. And one of these incentives, and we have seen this in this talk in the talk on knowledge, is that awareness of this relationship between soil biodiversity and stabilization of income or stabilization of yields can help them to conserve soil biodiversity. And this final message that we want to address in this paper is that when we are dealing with the value of soil biodiversity and ecosystem services from the economic point of view, we have two dimensions, the total output value and the natural insurance value. And probably all the challenges reside in this natural insurance value, the fact that soil biodiversity can reduce your income variability. Another important way to approach the evaluation of soil biodiversity is to deal with the regulating and the supporting services. This will help to classify the one who will benefit of the services in private actors like farmers, in the case of water regulation, for example, services, or society in the case of climate mitigation services provided by soil biodiversity. And the more general message of the talk is that the understanding of this value of soil biodiversity is a complex system of interaction between these biological processes, agricultural practices, and also the determinant of this total economic value and the presence of other markets outside the farm. So this is almost what I would like to talk to you today.
Any questions?
Yeah. Just as an exercise, have you tried to put figures?
Wow.
Yeah, to put figures.
Yes.
Simulation.
Yes. No, but we think about this. But okay. The thing that you have seen that in this graph, the one I showed you with the three diagram, you will need a lot of information to arrive to a monetary value of services, because there are a lot of services to list and still a lot of knowledge and a lot of work to identify the production function and how much yields or stabilization of income can soil biodiversity produce. In this eco-finder project, we try to estimate this production function with some long-term data, but it appears that the long-term data is not enough long-term for the moment for us to estimate this kind of production function, and then go further to the stabilization of yields, studying in the time the variability of yields. For the moment, we still have to have more data to go to a valuation exercise.
Thank you.
I have just a couple very quick. So what happens if the rational assumption doesn't hold? And what you think it could be implemented as, let's say, a subsidy policy in Europe?
Which assumption, you mean?
The rational agent assumption.
If the farmer is not rational, you mean?
Yeah, like for instance, in the oscillations, there's the chance that actually the farmer will have, let's say, good year, and that would create an incentive actually to keep intensification. So.
But he can have good yields in the good state of nature.
No.
But there are also states of nature that are bad in farmer, for example, and Just take like wind growers, if we are in Bourgogne. Wind growers, some years have large production and the other year have low production. So they will not stay always in the upper part of this variability. And subsidies, well, yes, it influence the degrees of risk aversion of farmers. Because it can be considered also that subsidies is like an insurance for them, because it's stabilized their income every year. I study, for example, maize producer in France, and half of their income is subsidies. And with this, we find, even though that they are risk averse, but with a very small degree of risk aversion. And in the model, when we get rid of subsidies, they are like much more risk averse.